Hey everybody, this is Miss Moran. We're in our Unit 8 Video 2 and we're going to be working with 3x3 systems to solve by substitution. So for this we're going to be discussing something we may or may not have ever seen, but it's a 3x3 system, and that refers to 3 variables and 3 equations. You may see some 3 variable systems with only 2 equations later on in this chapter, but today we're going to be working with 3 variables and 3 equations, and we're going to be using only substitution to solve them. Let's go ahead and take a look. Okay, for this first one, I've got my 3 equations and I see my answer, or see my variables are x, y, and z. What's very important when you go to write your answer is this is an ordered triple. Not an ordered pair, but an ordered triple, because I have 3 variables. And it's important that because it's ordered, that I put them in the correct order. And by that I mean you have to look at the alphabetical order of your variables. If I give you the variables A, B, C, they need to be written in your ordered triple in that order. If you're, in this case we have X, Y, Z, so that's the order in which they would be written. Alright, so my strategy for this is, I see they've already given me y, which means I already have a third of my answer. So I'm going to put the y equals 2 in there, and then I'm going to figure out what variable is the smartest one to solve for next. If I look at the last equation in my system, I only have 2 variables. So if I substitute in y, for 2 is y, then I'm going to be able to solve for my z. So then I'm 2/3 of the way done. So negative 4z equals 24, and z will equal negative 6. So there's my z. Then I can use both the x and the y to substitute into the next equation. So that means I will have 4x minus 3 times 2 minus a negative 6 equals 8. So this is 4x minus 6 plus 6 equals 8, or 4x equals 8, and x will equal 2 also. And that's my ordered triple. To check to see if this worked, you'd actually have to check this ordered triple into all 3 of our equations. The first one checks out, the second one we just solved for, and the third one. If I put in the z there, so I would have 2 minus 4 times negative 6 equals 26, I get 2 plus 24, or 26. So it does work in our third equation. Let's try another one. Okay, so this one, very similar to the last, I'm going to be starting on this one using the bottom equation. So I end up with z equals 1. So if I'm writing my ordered triple out and the lines are not required, I'm just putting them there to show 3 spaces, I have z equals 1. If I look up here, what's the next thing to solve for is actually going to be this equation by substituting in the z value. So 1 equals negative 2y plus 9. If I subtract 9, I get negative 8 equals negative 2y, and y will equal positive 4. Okay, then I'm going to take both my z and my y and solve for x. So x will equal negative 4 times positive 4 minus 2 times 1 plus 24. X will equal negative 16 minus 4 plus 24, and x will equal positive 4. And there's my answer for this one. Okay, so I'm going to challenge us with this one, and I'm not going to give anything away as we first look at this. I don't want to go, oh yeah, I've got a third of my answer and I've done no work. So we're going to have to do a little bit more examination on this one. And what I want to look for is 2 equations that have exactly the same 2 variables, because that way I'm able to solve a mini system with those 2, just like you did in Algebra 1. And that we've reviewed already, and then you're going to find the missing variables there to use to find the third variable. So let's take a look. The first equation uses x and y. The next one uses y and z, and the last one uses y and z. So I'm actually going to start by solving this mini system of just y and z. So I'm going to say, well, if this is what z equals, I'm going to put it right there. So I will have y equals 3 times negative 3y plus 15 plus 15. Let's continue. Y equals negative 9y plus 45 plus 15. If I go ahead and move this to the other side, I get 10y equals 60, and y equals 6. I've got 1/3 of my answer. Next, I'm going to take that y and I'm going to put it back into either one of these equations. It doesn't matter. I'm actually going to put it back into, show you with my pen, I'm going to put it right there. So I'm going to have z equals -3 times 6 plus 15. Z will equal -18 plus 15, or -3. Okay, there's another part of my answer. And last, I like that I have different pen colors, I'm going to take both my z value of -3 and my y value of 6 and see which one will help me find x. And in fact, I don't need the z, I only needed the y. So if I go back up to the top here, I'm going to have 4x plus 2 times 6 equals 4. 4x will equal plus 12 equals 4, or 4x equals -8, and x equals -2. So there's the process I took. I even color-coded it so you can follow it through, but I had to pick out 2 that actually worked for this purpose. Alright, you have a worksheet that has 4 problems on it using substitution of 3x3 systems. Okay, you also need to log into the Schoology class and take the quiz that's titled Entrance Slip 2 that matches this video. Make sure you bring any questions you have with you to class the next time we're together, and make sure that you feel comfortable able to solve a system with 3 equations and 3 unknowns using this method of substitution.